Okay, let's have a look. I want to zip through a few problems here. Practice problems. So let's look at some simplifying expressions involving numerical expressions, but the numbers are complex numbers, right? How are we going to deal with this? You know, order of operations, but what's that tell us to do? No, we can't do that.
3i over 4i times 4 plus 4i.
Okay, so you might be tempted here. You might be tempted to try to add up these fractions by getting a common denominator. We don't want to do that though, right? Because these fractions, these ratios of complex numbers are not simplified. First thing we want to do is we want to write those in a simplified form, right? We can't have i's on the bottom of the fraction. So we got to deal with this one, and we got to deal with this one separately. Question? I heard a question. Question? Nope. Okay, so let's deal with the blue one first, right? How are we going to simplify that? What's our recipe? So 3i. Good, so we're going to multiply top and bottom by the complex conjugate of the bottom. Good. So we multiply by 4 plus 4i on the top and bottom. Let's do the bottom first because that's easy. What do we get on the bottom? What plus what? 16 plus 16, right? Good. And remember where we get that. We know that anytime you multiply complex conjugates, you always get a squared plus b squared. So for the expressions on the bottom, for those conjugates, what's a? 4. What's b? 4. Good. So we're getting 4 squared plus 4 squared. Easy. Okay, that one's always going to be a piece of cake. Top one, we got to do a little work. But not as much this time because we only have one term on the top, right? So if we distribute that 3i, we're going to get 12i. Good, so we're going to get plus 12i squared. But what do we always do with an I squared? Good. The I squared just changes the sign of that term. Good, so we'll just go. So that just becomes minus 12, right? Because remember, I squared is just negative 1. Right? That's the definition of I squared. So we could simplify that. We want to put the 16s on the bottom. We can add up to give me 32. I want to flip that around so the real part comes first. And then I could reduce, couldn't I? Right? I could reduce both of those fractions. I could either factor out of 12, but let's not for now. That'll be more natural next week when we talk about factoring. For now, let's just break this up into 2 parts and simplify each one. Well, what does 12 over 32 simplify to?
1.
Okay, good. The number I could, so 4 goes into both the top and the bottom, doesn't it? So I could make that a negative 3 over 8, 3 over 8. And so the blue complex number becomes negative 3 eighths plus 3 eighths I, right? We got to do the same thing to the red one, and then I'm just going to add them up. Okay? So what about the red one? Red one. What do we multiply top and bottom by on the red one? Complex conjugate. Good. Okay, so of the bottom. So negative 1. Now, the negative 1 stays negative 1, though, right?
Yeah.
All we're doing is changing the sign in between the real part and the imaginary part. So negative 1 plus 4i, top and bottom. What on the bottom, what's a?
7.
Negative 1, what's b? 4. So we're going to get 17, aren't we? Negative 1 squared is 1, 4 squared is 16, so we get 17. Good. We distribute the 4i, we get negative 4i plus 4i, or plus 16i squared, what's that? Negative 16. So if we split those fractions up, we'll put the real part first. I get negative 16/17 minus 4/17 I. Right? And then all we have to do is just add the blue to the red, right? And combine like terms, right? Combine the real parts and the imaginary parts, and we got it. So what's that give us? Negative 3/8 plus 3/8 I plus all this stuff, right? So that's just going to be, if I'm adding this whole thing, I'm just going to be subtracting each term, right? That makes sense? So plus negative 16/17 is just minus 16/17 and minus 4/17 I. Well, it was a good suggestion. Let's combine the parts that go together. The real parts go together, right? It's getting very colorful up here. And the imaginary parts go together, right? So let's add the real parts up. So now we just got to go back and do some good old-fashioned adding fractions. So negative 3/8 minus 16/17. Okay, we'll get an answer for that. Plus 3/8 I minus 4/17 I. Okay. On those purple ones, they're both the terms with i's in them, right? For you guys, I'm going to talk about this a little differently. Now, anybody have a suggestion for what I could do with those purple? Instead of leaving the I with each one, anybody have a suggestion maybe? Okay, yeah, pull it out. Good, we'll factor it out. So this one right here, how about if instead we make that 3/8 minus 4/17, and whatever we get is just going to be multiplied by I, right? So we'll just factor the I out, okay? How are we going to deal with, those are going to be kind of ugly numbers, aren't they? To get a common denominator here, 17's prime, isn't it? Right? So, I mean, the smallest number I'm going to get that both 8 and 17 divide into is going to be 8 times 17. So we'll multiply this guy by 17/17. And what's that going to give us? 3 times 17 is going to be 51. Good, so we're going to get negative 51. And on the bottom, 8 times 17, how could you do that in your head real quick? 80, right? Good, because you're going to do 8 times 10. 8 times 17 is just 8 times 10 plus 8 times 7, right? So 80 plus 56 is 136. And then over here, we're going to multiply by 8/8. So we know we're getting 136 on the bottom. And 128, good. Okay, so all of that, while we're at it, let's just figure out what that combines to. We've got a common denominator of 136. What's negative 51 minus 128? Okay, so negative 179, 136. Okay, that's pretty ugly. Well, I don't know. Does that reduce? I don't think so. I don't think it does. And then over here, we're going to have the same problems. Right, we're going to have to multiply this one by 17/17, and that's going to give us, oh, that's convenient, so that gives us 51/136. And over here, same thing. Oh, sorry, times 8. So we get that minus sign, 32/136. And what's that give us? 51 minus 32 is what? 19, there we go. Okay,
How's that?
so our final answer looks like negative 179, 136 plus 19, 136 I.
Can't that be taken down because the 19 is divisible by?
Does the 19 go into,
No, never mind.
I don't think it does,
No.
38, no, it's not going to. Okay, so that's it. Okay, there's just a lot of arithmetic in that. It's, however, doing that arithmetic, do as much of it, especially you guys. When you're doing stuff like that, try not to just always go right to a calculator. Try to actually use your brain a little bit and see if you can crank through those numbers in your head. The more you do that, the better you get at algebra. It's the same parts of your brain that are active. Okay, let's look at another one. What are we going to do on this one? Maybe we don't have to go through the whole thing. What are we going to do on this one? Okay, good. We got to simplify. So we've got a quotient of complex numbers divided by a complex number, right? So we'll just take the top and turn it into one complex number, right? And then then we'll have to, once we get that, we'll have some complex number divided by another complex number, right? And so we gotta simplify that one again. All right, so that's a lot. Now let's go through it. I think a little practice won't hurt us. So in the purple box, how are we gonna deal with that one? Same way we dealt with them all. So -5 plus 2i. What do we get on the bottom? 29, right? Because we get a is -5, b is 2. -5 squared is 25, 2 squared is 4. 29, if we distribute the 5i, we're going to get a -25i. And 10i squared is, okay? And all that is going to be divided by, all that's going to be divided by 2 minus I. Okay, that looks pretty ugly, but what's something we could do here? When we divide, let's talk about this step. When we divide by a fraction by something else, we're really just multiplying by the reciprocal of the fraction, right? So this is actually a pretty good step to talk about. Everybody agree? So I've got the purple fraction divided by 2 minus I over 1. That's the same thing as the purple fraction if it wasn't no, then you wouldn't bother. But if it is a fraction in the numerator, we can make this a little simpler. So we're going to multiply by the reciprocal of the blue fraction, right?
Yeah.
Okay, so let's mix and match a little bit here. That 29 is just a constant. That's just there's no i's in that, right? Why don't we factor the 29? Just pull that out front, right? Because we can kind of mix and match here. I could split this up where I've got the 1 over the 29 and the -10 minus 25i over the 2 minus I, right? Everybody see that?
Yeah.
Okay. So okay, everybody see that? That makes things a little bit better. Does anybody see something else we could maybe do here to make the rest of this a little bit easier? Yeah, why not factor a 5 out of the top? Okay. In fact, we're going to be talking about this, we won't do it today, we'll talk about this on Monday anyway. When we factor out a greatest common factor, that's really all that is, right? I've got two terms here and I'm trying to factor out the greatest common factor. When I do that, I always want to factor out the sign of the leading term anyway, right? So let's, instead of factoring out a 5, let's go ahead and factor out a -5 and make it look even simpler, right? Is it essential to do this? No. Is it a good idea? Yes, very good idea. It's going to make the complex number we're simplifying a lot easier, right? And that's really gonna be, that's the hardest part of what we have left to do, is dealing with the dividing the complex numbers, right? So if we undistribute or factor out a -5, on the top, we're gonna get a -5, we got a 29 on the bottom. What's left behind? If I undistribute a -5, what's left in that top complex number? 2 plus 5i, good. And on the bottom, we've just got 2 minus I. Doesn't that look better, right? Now we got a lot easier complex number to deal with. This is a good thing to talk about because this is a lot of what math is about. I think I've mentioned this before and I'll probably say it a bunch of times all year. But like in my AP Calculus class, the stuff we're doing right now, the vast majority of the time that we spend on the problems we're doing now is that kind of stuff. It's pre-writing the problem so we make it easier to do when we actually have to do the hard stuff, right? And we do that a lot in math. Okay, so now what's the last part? Okay, and what's that give us? So we've got our -5 29ths out front. What's that going to give us on the bottom? On the top, we're just going to distribute and we're going to get what? 4 plus 2i plus 10i. And then what's that last one? -5. So we can. So then we get 4 minus 5 is -1. 2i plus 10i is 12i over 5. And now finally at the end, what do? Well, we don't want to leave it like that. We want to write our answer as a complex number in standard form, right? We want to write real part plus imaginary part. So we're going to redistribute that fraction, but that's easy to do. If we redistribute that on the top, I'm just going to get +5 plus 60i. And on the bottom, we're going to get 5 times 29 is, say it again? 145? Is that what I heard? And we could go one step further, couldn't we? We could reduce these things, right? So what, you guys saw something here that I hear people talking about. What could I have done to avoid having to reduce these big fractions? Yeah, look right there. Make that a -1. Right? Should be, that should be minus, shouldn't it? You're right. Yep. Good. And let's go ahead and let's make this simpler. Now if we distribute, we're going to get 1 minus 12i, and our denominator is just 29. Right? Like that? Okay? All right. So there's a lot to those. There's a lot of steps. In comparison, these are actually probably easier. Those are probably I would say those are probably the most involved questions you have to do on all these items.
Would that type of question be better?
So I'm not going to give you the really, just because they take so long, I'm not going to give you the really, really long ones on the test. Just the kind of hard ones, yeah. Okay, so let's zip through just one of these. How about, let's do this one. This one's a little tougher. All right, so always, when you're doing these things, just take a pause, look at the problem, and kind of identify what are we trying to do here, what's my strategy. So what's the goal? Good. Single x, so we're going to solve by isolating x. And remember what we're doing here, this is clearly an equation, right? We're solving an equation. We're trying to find the values of x, that satisfy the equation. So our technique is to isolate x, right? So first step, subtract 5. Good. So that's gonna give us 6 times the quantity, negative 2x minus 5 squared equals negative 100. Now what? Divide by 6. That gives us negative 2x minus 5 squared equals negative, what's that reduced to? 50 over 3? No. Yeah, 50 over 3. Okay, now what? Square root. Okay, so step 3 is square root both sides, right? Okay, so while we're doing the square rooting, we know that we're going to get something like negative 2x minus 5 equals plus or minus something, but let's go ahead and try to simplify that, right? So there's a couple important things going on here. What's one thing I've got to deal with right away when I've got a square root of a negative? I. So we know that the negative inside is going to become an I outside. Very good. Okay, what about if I have the square root of a quotient like that?
You do like split it into two.
Perfect. Split it up, square root of the top, square root of the bottom. Okay, now what?
Simplify.
Simplify. Bottom we can't simplify, top we can. What's the top break down to?
2 radical 5.
Good. Or 5 radical 2. 5 radical 2. So plus or minus 5 radical 2 over radical 3. And then we need one more line, don't we? So the last step would be, I need my I. What do I do to that? There's one more thing I got to do. Good, I gotta take the 10 out of the base, but I have to rationalize the denominator. So we gotta multiply top and bottom by 3. Good. And that gives me, finally, plus or minus, on the top we're gonna get 5
Radical 6.
radical 6. On the bottom we get a 3, and we get our I. Good. Okay, so okay, last 2 steps to solve for x then.
Plus 5.
Plus 5. Okay. Right, put that in front of the plus or minus. So that cancels those guys, and then finally, okay, divide by negative 2. Right, so now we've got the equation negative 2x equals 5 plus or minus 5 radical 6 over 3i. So talk to me about dividing by the negative 2, because we've got to be very careful about this step too.
Multiply by the reciprocal.
Okay, we're just multiplying by the reciprocal, aren't we? Okay, so that's going to give us, dividing by negative 2 is going to give us, this term is just going to be a negative 5/2. No big deal, right? Okay, the other one. I've got a fraction here. Am I going to multiply, you tell me, what am I going to do?
Multiply by negative 2 over 1. You just put it in.
By what?
1 over 2.
1 over 2, not 1 over negative 2, right? How come?
Because positive.
Because I got a plus or minus, right?
Oh.
Right, so multiplying by a negative, what's that going to do? I'm going to get plus or minus a negative, and still just plus or minus something, right? So we never complicate things by multiplying or dividing this term by a negative. So we just multiply that one by 1 over 2, which gives us 5 root 6 over 6, right? Times I, and then I can't reduce anything, and so those are my 2 answers. Okay? Make sense?
Yeah.
All right. Why don't, how much time we got? When are we out of here?
25.
25?
We got a lot.
Yeah, like,
Yeah. Okay. Okay, so I'm just gonna do one quick thing here then. I wanna start your thinking about something, right? Because I really wanna get it, you got tonight to finish studying, okay? If you want me to get you for TA today, let me know if you have some questions on things. I'll get you for TA, come on in, and I can answer questions then. But I want to just start you thinking about the next step. Okay, next step for us is going to be What if we have an equation like, for example, something like this? We'll start with an easy one. What if I have something like x squared minus 5x minus 36 equals 0? Okay, what's different about this equation than the ones we've been working with? It's got an x squared and an x, right? So is isolating x an option at this point?
No.
It's not really. It turns out that there is a way we can force that to work by doing something called completing the square, but we're not going to talk about that yet. Right? We'll do that in a little bit. Let's talk about another option, right? So factoring, right? Sometimes it doesn't always work, and because it doesn't always work, we're going to kind of think of this like a tree, right? We're gonna start at the top. We got a quadratic equation, and we're gonna work our way down the tree diagram, and we're just gonna ask ourselves, okay, is this strategy appropriate? We'll look for the easiest ones. If we can isolate an x, we're done. We isolate the x by doing the stuff we've been doing. That's the easiest way to solve a quadratic equation, is isolating x, if you can. We always look for that option first. If we can't isolate an x, sometimes we're going to be able to factor, right? If we can factor easily, we're going to do it, right? If we can't factor easily, or we can't factor at all, we'll move on and use another technique, right? We'll kind of work our way down through the hierarchy of try the easiest stuff first, and if that doesn't work, we move on to the harder options, right? So I'm just curious what you remember about this. Do you remember how this factors?
The only other point you know is that multiply together to equal negative 56 and 2 by 2.
Okay, good. So numbers that multiply to the constant and add to -5. What are they?
-4, -9, and 4.
-9 and +4. Okay. Now there's a couple ways. Have you guys done a lot of this? I'm just curious. How much of this did you do? Did you do this last year? Okay. Okay. So you did this. Okay, not last year, but you did it in Algebra 1, right? Okay. So give me a little feedback here. What's your comfort level on factoring? Yeah, we're going to cover it anyway, but I just want to know where we're starting on this. Give me a 5 if you feel like you really know factoring well. Okay. Okay. All right. Okay, so that's good. That's good. I want to point a couple things out, though, because sometimes I would guess, probably you're pretty good at the factoring skill. That's probably something you worked with. But sometimes what happens to people when they start to look at harder factoring problems, and we're going to deal with factoring problems beyond quadratics, too. We'll deal with factoring cubics and things like that, where it gets a little more complicated. Sometimes where things fall apart for people is if they're really good at the skill, but they're not keeping a really good idea or kind of a big picture idea of why we're doing it, how you set this thing up. So I want to start off by just emphasizing, how does factoring work the way it does? What's the overarching strategy? Do you remember something called the zero product property?
Yeah.
Okay, right. But you guys have talked about the zero product property? Raise your hand. Give me a 1 to 5 on if you remember exactly what that means. Okay, that's a 0. Okay, we're at 0. All right.
If your answer is
Raise your hand, please. Good.
If your answer is 0, then one of the factors has to be.
Right. Right.
So
Yeah.
then you can deduce the answer of one of the terms, or one of the answers of that.
Right. Okay. Good. Good. Yeah. And we're gonna. But I don't think everybody's on the same page with that. So I want to kind of start with that. So if we break this into factors, you guys already know how to do that. Let's take a second and just review how we go through those steps. So we know that the first terms in this case have to be an x, and I'll defend that in a different way tomorrow, or the next day, or how about you guys take the weekend off on Monday maybe. But think of it this way for now. Factoring is the opposite of multiplying, right? You're very good at things like this. This is no sweat to say x minus 2 times x plus 5 equals, and you just FOIL it out. No big deal. What are you going to get? X squared plus 5x
Minus 2.
minus 2x is, okay, that's easy, right? That's the easy direction, right? That's the direction that we call expanding. Or multiplying. See, we want to flip this around and we want to do the opposite. We're doing factoring, which is the harder direction, for sure, okay? So we know here, if we're factoring this, we know that if I were going to FOIL this out, the first term times the first term would have to give me x squared if I were going the opposite direction. And so for now, let's just use that as our justification for why these have to be x's, okay? That's going to change if there's a coefficient in front of x squared, okay? Now then we'll have a little different process. And we'll show that they're just the same process. This is just a simplified version of that. If the coefficient of x squared is 1, the harder process just gives us the same answer in an easier way. You'll see what that means later. We're not going to worry too much about it for now. But finding these other numbers, there's a few steps you can go through. First one is what I call the sign game. If the two numbers here, you know they have to multiply to this number, right? So let's put an M over that. And they have to add to this number, right? Okay? So if they have to multiply to a negative number, what does that tell you right away about the signs of the two numbers? Good, they're opposite signs, right? So this is what I call the sign game. This helps to play. You know that if they multiply to a negative, you've got a negative and a positive. What if they multiply to a positive? What's one possibility? Okay, both negatives or both positives, you know they're the same sign, right? So right now, we know that both of these are opposite signs, right? Okay, if they're opposite signs, we can go one step further than that. If they're opposite signs, but they add to a negative, what can you tell me about those two opposite numbers? The negative one is bigger, right? So let's always get in the habit when we're factoring of putting the biggest one first, if we know which one's the biggest one. So we'll go negative, positive, and then we know to look for the bigger number is going to be the negative one. And then we just kind of have to think about factors. What are the factors of 36, that are going to work here? And the only one that works is -9 and +4, right? Okay, here's the important part of this. The product equals 0, right? I want you guys to kind of warm up a little bit. We're going to be doing some mental math here, and I want you to get a quick warm up. So I want you to do this. You can write these things down if you want to. Just get a little corner of your scratch paper here. You can write the numbers down if you want to, but I want you to do this in your head. And I want to see how many people can get this right at the end. So start with the number 7. Okay. Okay, multiply 7. So you're going to multiply by 5. That gives you a new number in your head. You're thinking about that. Multiply that by 2 times -13. Keep going. Times 185.3. Okay, in your head, you gotta get this going. Come on now. Times 14.397 times 0 equals 0. Okay, it doesn't matter how complicated it was. If I multiply by 0, the answer is always 0. There's only, in fact,
Nope, I'm done.
You do that in your head, or you?
No.
I did not.
So there's you know that if the only way you can get 0 from a product is when you multiply by 0, right? Makes sense. If you're adding and subtracting stuff, it's more complicated. Different ways to get 0. But if you're multiplying, you have to multiply by 0. So the zero product property just says this: if I have a product that equals 0, then guaranteed that can only happen when at least one of the factors is equal to 0, right? And so if we're trying to find all of the solutions to an equation, and that's what we want. When we solve an equation, we want to find all the values of the variable that satisfy the equation. But we're just going to look at all of the instances of 0 factors, right? What are the ways that this could multiply by this and get 0? And I know that you guys know this, but I want to just say it clearly in a mathematical way. So you kind of makes sense, right? So it makes sense theoretically, kind of conceptually. So what if this one is equal to 0? If x minus 9 equals 0, then what does the value of x need to be? 9. So x equals 9, or, yeah, or this one could have been 0. So x would have to equal, right, so there's our solutions, okay? The reason I bring that up is here's a common mistake, and I doubt you guys are gonna make this mistake, but I see this a lot. What if we had something like this? What if we had x squared minus x? Okay, let's do. Okay. Okay, what's the first thing I have to do here? Good. Good. You get that? Because sometimes what people want to do is say, okay, well this I can factor this. What are two numbers that multiply to -1 and add to negative? Well, I guess that wouldn't work so well, would it? I probably should have done. But let me make one little change here. Now that would work, right? You could find numbers that multiply to -2 and add to -1, right? -2 and +1. But that's not going to help us because the other side isn't equal to 0. So if I factor this, all it's going to tell me is the product of two factors equals 28. Big deal. That's no help at all, right? We have to get 0 on the other side. We have to put the quadratic equation into what we call standard form, which is where it's equal to 0, right? And then we can factor. So the first step has to be subtract 28 from both sides so we get 0. And now, what would the magic numbers be? -6, +5. So what are the solutions? Good.
Could you just use the little V thing, or is that?
What's the little V thingy?
You know that one, the or V thing?
Oh, yeah, yeah. In Moodle, what you're gonna do is you're gonna put 6, -5.
Okay.
Yeah. Okay, one more.
I love this one.
Go out.
Okay. What can you tell me about the signs here? It's equal to 0, so we'll try to factor it. So if the numbers multiply to a positive and add to a negative, what's it tell you about their signs?
Oh,
On negative. Okay, good. So you got this.
Negative. All right, I think I've bumped up to a solid 4.
Got it. Okay, good. Okay, how about this? What are we at here? 25?
Yeah.
Okay. Okay, what about that? Okay, yeah, so this kind of looks like, right, at first glance, this looks a lot harder because it gets harder to factor when a is not equal to 1, right? When the coefficient of x squared isn't equal to 1, right?
So you just like factor on.
Okay, good, good. So, moral of the story is you always want to try, whenever you're solving any equation, you always want to try to factor out the greatest common factor. It always makes things, if you can, it always makes things much easier, right? In this case, what could I factor out of it?
3.
3. If I take a 3 out, what am I left with?
X squared minus 2x.
Okay, and so if we wanted to, now we could, let's leave that 3 there for now, okay? I've got 3 times the factor x squared minus 2x minus 10. Then we want to ask ourselves, okay, the 3's done. That's a constant factor, we can't break that down any further. And we don't want to. But what about this one? Does it break down further?
Yeah.
5 and 2 are probably.
Can we think of numbers that multiply to negative 10 and add to negative 2? I guess we can't we? Okay, so we'd be stuck with that at this point, right? Okay. Okay, last one. Oh, we'll do, never mind. We'll get it Monday. Forget it.